guys, so now let's solve these questions from your term 3 tutorial sheet. I don't know if it's tutorial sheet or assignment, but these are some of the exam questions which they might bring on your sessionals, okay, on integration to be specific. Yeah, I don't think they can go beyond these questions, and I'm going to solve all of them in this video with the explanations. So let's begin with this one. And I've already taught like all these things, like how to approach each and every question here. For those of you who have subscribed to our platforms, where you're going to find the full videos, the full video lessons. With this video, I'll just focus on solving. So on our platforms, we have our very own app, and on Telegram, our video lessons are there, where we've taught like everything. All the NS topics have been taught in biology, physics, math, and chemistry. Yeah, so make sure that you subscribe. You're going to find all the pre-recorded videos. Without wasting much of the time, let me now start solving. Let's start with the first one, this one. Okay, I hope that you take note in case maybe you want to be following along. Maybe you can just maybe try to pause the video and then take note of the questions. Maybe I might not come back to this page. Okay, now let's solve. Okay, let's start now. So this question, this is the definite integral, right? So what you do is that first you're going to begin by integrating this. So I'm going to say first we find the integral for natural log x over x with respect to x, right? And we are going to use substitution here because the derivative for this one the derivative for the denominator, it can give us what is here, right? So this means that my u is going to be natural log x, right? So let's find our du. So I'll say du is equal to 1 over x dx. I need to make dx the subject, so I just cross multiply, say x times du. I've already taught this in my videos, so right now I'm just trying to apply what I've already taught. If you're somebody who don't understand, you then try to go and watch my video where I taught integration by substitution. Okay, so I've just cross multiply, then here I have dx. So now let me just rewrite this one here. Okay, I'll just rewrite this, but this time I'll substitute, whereby first I'll write the integral symbol. Then while there's natural log x here, I'll substitute with u because we say that u is equal to natural log x. So I'll say u is equal to x. Then while there's dx, I'm going to put this one. Okay, so it's going to be x du. Then this and this, they're going to cancel each other, right? So I'm going to remain with u du, just like this, right? And then we can now proceed and apply the power rule for integration. So we just say u 1 plus 1, right, over 1 plus 1. This is going to give us u power 2 over 2, right? So let me just continue from on this side. Okay, I'll continue here. I don't want to go on another page. I want you to be seeing this. Okay, so this is our integral. Now, you're not done it. Remember, we say that u is equal to natural log x, right? So where it is u, I'm going to substitute with natural log x. So it's going to be natural log x power 2 over 2. So this is now the integral. If you want, you can even say plus c, but we're not ending from here. We need to now substitute the limits. We have these two limits. We have the upper limit and the lower limit. So the one that we substitute first is the upper limit, right? So it's going to be natural log x. So let me do this. So natural log, so where is x? Where is x, I'm going to substitute e. So I'm going to put here, which is the upper limit. And then power 2, right, over 2. Then we say minus. Now, for the second one, we are going to substitute where this x with 1, which is the lower limit. So it's going to be 1. Let me just say power 2 over 2. So before I even simplify, if you remember what I taught on logs, for you guys who have been watching my video lessons, on logarithms, I mean natural logarithms, I gave you some of the identities or some tips that whenever you have natural log e, it is same as you are having 1. Whenever you have natural log 1, it is same as you have 0. I hope you remember these identities. Yeah. If you want, you can try to punch this on your calculator. They're going to give you what is here. Try to punch natural log 1. It's going to give you 0. So what I'm going to do right now is that here I'm going to put what? 1. Here I'll put 0. So it's going to be 0 power 2 over 2, right? Minus. And here now I'm going to say, no, I mean here we have to put 1. Why this e? 1 is supposed to be here, then natural log 1, that's why we're supposed to put 0 now. Yeah, I swapped them. Okay, so when you simplify, this one, it won't give you undefined because 0 is on the numerator instead of the denominator. If 0 was on the denominator, it would have been undefined. So it's just going to give you 0. This one, because if you raise 1 to the power of 2, it's still gonna remain 1, right, over 2. So the final answer is simply going to be 1 over 2. So just like this, you're done. Okay, so this is how you handle the definite integral. Unlike the indefinite, for the definite integral, the final answer is a constant, which is the number here. Now for the indefinite integral, that's why now you just end here. You just say plus c, you even end here. Now if they have given you these limits, you have to go a little bit further till you simplify. Yeah, so let's go to the next question. Okay, so now let's solve this question. So for this question, they have given us this one, and they want you to integrate, and the limits have been given. So at first, you're going to focus on integrating. So first integrate, then after you integrate, then you substitute the limits. Okay, so how do you integrate this one? So we are going to use substitution, because whenever I try to differentiate what I have here, I'm ending up getting what is here. I'm ending up getting the other function. So this is the right time to use integration by use substitution, or just substitution method. Just that we use letter u. So most of the people call it use substitution, but let's just call it substitution. Okay, so I'll say my u is going to be what is under the root. So it's going to be x power 3 plus 1. For you who don't understand, I've already taught how you can know whether to use substitution method or not. I've already given out the tricks, and how you can know whether to use partial fractions, integration by partial fractions or integration by parts. I've given the tricks that you can use to know, because on the exam they won't tell you whether to use integration by parts or whether to use integration by partial fractions, or what is this, the substitution method. They won't tell you. They'll just give you a question and tell you to integrate. So make sure that you make use of those tricks which I taught in my full lessons. Let's proceed. So I'll say du is equal to, I need to find the derivative for this one, which is just going to be 3x power 2. I won't include plus 0 because we know that there's plus 0 here. So I'm just going to say now, here there will be dx. I need to make dx my subject, so it's going to be 3x power 2, right? So I'll say dx is equal to du over 3x power 2, right? Now let's just rewrite this one here. So I'll say, okay, let me first write the first function, this one, right? Then I'll write the square root, and then under the root, I won't put these, I'll put u instead. So I'll say u. Then here now, instead of putting dx, I'm going to put this one. Okay, I'm going to substitute dx with what I have here. So I have du over 3x power 2. So this and this one, they can cancel, right? Because they can be cancelled out. That's the purpose of substitution method, something has to be cancelled out. Okay, so now what have I just remained with? I've remained with, let me write that one properly, something like this. So I've just remained with this one, right? Du over 3, right? Now, do you know that if I want, I can simply take this 3 outside. So I can say 1 over 3, right? Then I'll just remain with square root u du. Now we can deal with this one alone. So let me just write 1 over 3. Then we say u power 1 over 2. I say that whenever you are either integrating or differentiating, normalize writing the roots in this form, in exponential form, like this, instead of just dealing with the square root, so that you can easily apply the power rules. So I'll even say du. Now let's integrate this one. I'll just continue here so that we don't go on a different page. Okay, so right now I have 1 over 3, right? 1 over 3. Okay, let's use power rules. So here I'm going to have times u. Whatever I'll get after I integrate. Let me just do this. I put a demarcation there because this is not part of what I'm doing right now. So here I have 1 over, let me do this. Let me make it a little bit bigger. U power 1 over 2, right? So I'll say plus 1. Remember, we are integrating, right? So I have 1 over 3 times, what is 1 over 2 plus 1? It's going to give you, 3 over 2. So it's going to be over 3. Let me do this. 3 over 2, right? So right now, your job is to just simplify. And how can I simplify this one? I just I can multiply this with this one on top. So I'm going to have 1 over, then this one I multiply with this one. It's more like you have this divide by this. So if you are somebody who's confused right now, just write this one divide by this one. You can use that grade 1 approach where you solve everything step by step. But if you have advanced your levels, you can simply just say this times what is on the numerator, then this times this one. But for you guys who are confused, just use the step-by-step approach. If you're not good at these shortcut methods, these ones, don't force yourself to use what you're not used to. That's the mistake the majority of you make. Yeah, you are trying to use a method that you're not comfortable with, then there is also a method that you are 100% comfortable with. You decide to abandon it. So don't do that. So let's now multiply. So I'm saying a have 1 over 3. So a is going to be, first when I multiply this is going to be 2. U 3 power 2 over 3. Now I can multiply the denominators, right? So finally I'm going to end up having 2u 3 power 2 over 9 when you simplify that one. So if you want, you can just write here. So right here, if you want, you can substitute what is u. What is the value for u? The value of u is actually this one. Listen, don't leave your final answer here. Like, don't write u as your final answer. Where there is u, substitute what is corresponding to u. Okay, I'll just continue here. So I can say 2. Why there is u, I'll put what? I'll put this one here. So it's going to be x power 3 plus 1, right? And for you guys who don't have the full solutions for this whole document for term 3 that they have released, make sure that you subscribe. You're going to access it. It is available for those who have subscribed. So we are raising it to the power of 3 over 2 over 9. So if you want, just end here. No, don't do that. I mean, I've just observed that we have the limits, but if we weren't given the limits, if you want, you don't have to, it's not a mandatory that you should write it back in the root form. Okay, some lectures will still mark you, yeah, but since we are going to plug in some of the limits, I'll just go beyond. Okay, so I'll write 2. I'll do this. So here it's like this 2, right? Then here it's like I have x power 3 plus 1. I can also write the whole thing like this one, like the way I'm writing right now. So if I want, I can write it like this. And actually, this power 3 on top is going to be here. Have you seen? So now our job right now is to substitute x with the limits. Now let's apply the limits. So what we are going to do is that, remember that the upper limit, when you look at the initial question, which was right there, the upper limit is 2, right? The lower limit is 0. So I'm going to put, first let me write 2 square root. So where is x for the first one? I'll put the upper limit, which is 2 raised to the power of 2, right? Plus 1, right? Raised to the power of 3. And then let's say over 9, right? So I've just substituted the upper limit, which was 2, why this x, and the whole thing is raised to the power of 3 minus, now this time I'll substitute the lower limit, which is 0 power 3 plus 1, right? And raised to the power of 3 over 9. Yeah, now let's just simplify. When I raise 2 to the power of 3, I get 8, right? 8 plus 1, that is 9, right? So it's going to be 2, 9, raised to the power of 3 over 9 minus 2. Here, if I raise 0 to the power of 3, it will still be 0, right? It's going to be 0. It's going to be 0. 0 plus 1 is going to be 1 power 3 over 9. Okay, now, how do you simplify this one? So what you do in this case is that first, find the square root of 9. Then, the number that you're going to get, you're going to raise it to the power of 3. So it's going to be 2. What's the square root of 9? The square root of 9 is 3, right? So 3 power 3 over 9 minus, even here same thing, square root of 1, it is 1 power 3. This is how you solve this one. For you guys who just saw how I solved it in the document, because there it was very hard for me to explain this. Yeah, so I just wrote it thinking that you're going to understand. But if you understood, then you must be very lucky. Okay, so now what is 3 to the power of 3? Isn't it 27? So 27 times 2 is going to give you 54 over 9. Then here it's just going to be 2 when you simplify the numerator. Now we have, so solve step by step, okay? You don't have to rush. And use the methods or the approaches which you are comfortable with. Just because I've used a shortcut, it doesn't mean that you also have to use a shortcut. You have to go step by step. So what I've just done right now is that I've just say this into this, 1 times 54, 54. This into this, 1 times that, it is this one. And then you are going to just subtract. This is the common denominator. And then it's going to be 52 over 9. This is our final answer. I hope that you've understood. Let's go to the next question. Okay, so now let's solve this one. So for this question, I'm going to use the Liate approach, or I'm going to use the integration by parts, because we cannot use what is the substitution method. Okay, so according to what I taught you, whenever you're using integration by parts, you use this formula, this one here, u du is equal to uv minus integral of v du. Remember this one, right? So now u, in this case, according to Liate, that strategy that I showed you, the strategy to use to determine the value of u, which is this one. Let me just write it here. Okay, right here, Liate. So when you look at linearity between the exponential and the trigonometric function, which one is coming first? E is representing the exponential, T is representing trigonometric function. So the one that's coming first is T, which is the trig function, which is sine, right? So my U is going to be sine. I taught you how to apply this strategy to determine the value of U. So I'll just say sine U is equal to sine X, and then we now find our dv. dv, for the fact that this is our U, it means this one is automatically our dv. So it's going to be e to the power 2x. Now let's find du. Du is simply this one here. So u is this one. So du is the derivative of what is here. What's the derivative for sine x? The derivative for sine x is cos x, right? So I'll say cos x. Then we know our dv, that it's the other one, right? Now what is our v? Our v is what we get after integrating. And I showed you that whenever you're integrating the exponential, you just say e2x over the derivative of this one, the power that is here, whatever they have raised the e to. So it's going to be 2, right? Now let's just substitute in the formula. So it's going to be e, and actually this one, it just represents what is here. So okay, let me start with sine. Okay, look, so what I would do is this one. U is sine, right? Du is this one. No, it has to be dv. Yeah. So U is this one. dv is this one here. So the formula, du is just the one that is here. It should be here. dv should be here. Almost wrote v as u. Now I've confused myself, but don't make the same mistake. This is now the actual formula. Okay, so I'm saying that u is this one, right? And then dv is this one, right? Now you know that since we're multiplying them, if I want, I can start with dv, then I write u. So I'll start with so if I want, I can begin by writing this one here. So it's going to be e to x, right? Then I'll write sine x. So basically we just write what has been given here, and I'll just say is equal to u is sine x, v is this one here, so it's going to be e to x over 2. Yeah, and then say our v again. Our v is this one, 2x over 2, and then our du is this one here, so it's going to be cos x, right? Now let's try to simplify this one here. We can simplify this one by taking out the over 2, right? So it's going to be e to x sine x is equal to sine x e to x over 2, right? And so I want to take out this 2 on the denominator, so I can write 1 over 2, right? And I'm going to remain with e to x cos x. So now I'm going to focus on this one without the 1 over 2. So what I'll do right now is that I'm going to integrate it alone. I'll integrate it alone, whereby I'll say let's integrate. Let's find the integral for e to x. So we're going to integrate again by using the same formula, but for this one, okay? So I'll just say cos x. Yeah, so what I was saying is that I'm going to now integrate this one. Then after integrate, whatever that I'll get by using this formula, this one here, I'm going to substitute back here. Okay, so now again our u is going to be cos x. then our dv is going to be e2x. This means that our v is again going to be, it's going to be what? It's going to be e2x over 2, right? And our du is going to be, what's the derivative for cos x? It is going to be negative sine x, right? Now let's just substitute in this formula again. So where is u? So I'll just write this function, because substituting here will give me back the function here, this one, what I was differentiating. So I'll just say e2x cos x equal to, then where is u? Okay, so I was just saying that where is u, we are going to put cos x. This is an equal sign, guys, so let me just write cos x. Then where is v? I'm going to put this one, so it's going to be, I feel like I've forgotten something. Okay, I haven't. Over 2, right? Then yeah, this is v. Okay, and then we say minus, again we write our v, which is simply this one here, right? It's going to extend there. Then we write our du. Our du is this one here, negative. So it's like we have a negative here in front. Okay, it's like we have a negative. Okay, let me just write it in brackets. So I'll just write negative sine x. Yeah, just like this. Okay, and then now what we're going to do is that I'm going to simplify this one a little bit, whereby, let me show you. So I'll say, let me write it properly down. e2x cos x is equal to, we say cos x, we've written cos x, right? Then we say e2x over 2, right? So this negative and this negative, they are going to give us a positive, right? They are going to like cancel each other, and then these 2, I'm going to take it out. I'm going to write it as 1 over 2, so that I can just remain with e2x sine x. At least they look more nice. This is x. So now what I'm going to do right now is that first of all, let me walk you through what we've just solved so far. So at first, after integrating the first one, we ended up with this one, right? Then I took this portion here, this one, I integrated it, then I've ended up with this one. So now if you see this integral of this one, which is the integral that is here, it has given us the whole thing that is here. So what I'm going to do right now is that I'm going to substitute what I have on this side into this one. Okay, where this integral of e to the power of 2x cos x, I'm going to put this, we are going to swap them, we substitute them, so you guys will understand. So let's just do that right now. Okay, so this is the first one that I found, this one here. This is the second one. So I'm just going to take everything that I have here, everything, I'm going to substitute it there. Okay, so it's going to be e2x sine x is equal to sine x e2x over 2 minus 1 over 2. Now here I have to substitute what I've just gotten, the whole thing here. So it's going to be times cos, cos x e2x over 2 plus, this is very long, how I don't run out of space, so 1 over 2 integral e2x sine x. Yeah, so now let's simplify. So right now our job is to simplify. So say 2x sine x is equal to sine x e2x over 2. So I'll just multiply through now. This multiply through. So I'll say negative cos x e2x over 2 times 2. That will be 4, right? this times this is going to be it's going to give me a negative as well. So it's going to be this, this times this one, these two times this one here is going to give us 1 over 4, right? Integral e to x sine x. Okay, so right now we are just going to simplify. So how do we simplify? This and this one here, if you try to check this and this, these two are like terms, meaning that we can sum them up, right? They can be added together. So what I'll do right now is I'll just take this one on the other side. So I'm going to end up having e to x sine x. When this one, when it comes here, the sign is going to change, so it's going to be plus, again, integral, let me just write 1 over 4. There's 1 over 4 in front, so integral 1 over 4, 1 over 4 integral e to x sine x, right? I've just taken it on the other side, on the left hand side. Now I've just remained with these. Okay, so now it's going to be sine x e to x over 2 minus cos x e to x over 4. Now these two can be added, and the way that you're going to add them is by just focusing on the coefficients. It's like here there's 1 as well. Okay, it's like there's 1. These are same things. It's more like you're trying to say, for you guys who don't understand, imagine it's like here you have here you have x and here you have x. Like you have 1x plus 1 over 4x. Okay, now where x is this one, I hope you understand. So what is 1 plus 1 over 4? So when you try to sum that up, it's going to give you 5 over 4. Then integral, let me write them properly, e to x sine x. Yeah, then we say equal to, so it's going to be sine x e to x over 2 minus cos x e to x over 4. Now our goal here is to make this alone the subject of the formula. Okay, I don't want to end, let me just say, I don't want to write my final answer having this one with a coefficient or a number in front, which is like in this case we have 5 over 4. So what I'll do is that I'll divide through by 5 over 4 over 5 over 4, right? So mean that these can cancel, right? Now let's come to this portion. How do we simplify here? So the way that we can simplify this one is by, so use whichever method you want. Okay, if you want to use grid bound approach, or if you want, you can simply multiply what is on the numerator with 4, then remain with 5. So it's like I'm multiplying 4 times this whole thing, 4 times this whole thing over 5. So 4 times this one, they're going to cancel. Here I remain with 2, so 2 is going to be in front here. Then this times 4, it's just going to cancel out. So my final answer is going to be e to x sine x. So our final answer is going to look like this. 2, which is what we got after this one, it was divided into 4, right? So it's going to be 2 sine e to 2 sine e to x minus e to x cos x, which is just the same thing. Listen, there's no big difference between these. If you want, you can start with this one or this one. It doesn't matter as long as they're multiplying. So 4 was cancelled out when we were multiplying with 4. We multiplied the whole numerator with 4, and we remained with 5 on the denominator. So you can simplify like this one. And since this is not a definite integral, you can even say plus c. Yeah, so plus c. So just like this, you are done. Let's go on the next question. Okay, so let's now let us integrate this one. So for this one, we use integration by partial fractions. Okay, so let's solve. So our first step here is, before we integrate, we are going to decompose this into partial fractions. So to decompose, I'll just say 3x plus 2 over x plus 1 power 2, say equal to a over x, which is the first one, a over x plus b over x plus 1 power 1 plus c over x plus 1 power 2. I hope you remember these rules, these tricks. So here, just go back to partial fractions if you've forgotten. For you to solve this question, you need to know how to decompose a fraction into partial fractions. So we are going to multiply this throughout so that we can just remain with the numerator. So you're going to remain with 3x plus 2 when you multiply this one with the whole fraction. When I multiply with this one, it's going to give me a x plus 1 power 2. When I multiply this denominator here with this whole fraction here, it's going to be b x plus 1, right? And then when I multiply this denominator with this whole fraction, it's going to give us plus c. So for this one, it's just going to be cx because this is going to be cancelled out with this one. Okay, so if you want to use whichever method that you're comfortable with, okay, as long as you've decomposed, that's what matters here. They just want you to decompose. So as long as you've decomposed, so I'll use the method which I like. So what I'm going to do right now is that I'm going to expand. So when I expand this one, it's going to give me a x power 2 plus 2x. I've just expanded this one, and 2x plus 1 plus, when I expand this one, it's just going to give me b. When I multiply this throughout, it's going to be b x power 2 plus x, right? And then we say plus cx. So let's just now multiply through. So it's going to be 3x plus 2. It's going ax power 2 plus 2ax. This is the method that I like using. You can use the method that you're comfortable with. Okay, bx plus bx plus cx. Okay, now let's equate the corresponding terms. So let's start with those that are having x power 2. Here it is none, here it is a and b. So it's going to be a plus b. And then let's go to those that are having x. So we have 3. It's equal to, I've taken 3. And I'll say 2a plus bx. Don't write x. Even if you do, it's still going to be cancelled out. So this is my final equation. So I can call this one my first equation, this one my second equation. Then let's equate those that are not having x. So I have 2 is equal to, if there is only a that is not having x, so I'll say a. So already we know the value of a. So since the value of a is known, I can call this, if I want, my third equation, but this is also the value of a. So a is equal to 2. So we know what is supposed to be here, right? Now our job right now is to just find b and c. Then we substitute. Then we're going to integrate each. So for me to find b, I'll take the first equation. So I just make b the subject of a formula, which is negative a. So basically, b is simply negative 2. Let's now find c. So to find c, I'll take the second equation, which is 3 is equal to 2a plus b plus c. And I'll just say, let's first substitute. So 2, where this a, I'm going to put 2 there, and then plus b. Where this b, I'm going to put negative 2 plus c. 3 is equal to 4 minus 2 plus c. So 3 is equal to 2 plus c. 3 minus 2, I've just taken this on the other side. So I'm going to say is equal to c. So c is equal to, c is now going to be equal to 1. So now we know the values of a, b, c, right? Let's just substitute where this a, I'm going to put 2, so it's going to be 2 over x, right? Plus where is b, I'm going to put negative 2 over x plus 1, plus where is c, I'm putting 1 there, over x plus 1 power 2. This is power 2, guys. Yeah, so now right now our job is to integrate this one, and integrate this one. Whatever you're going to get will be the final answer after you integrate. So let's integrate these. Let me just start on a separate page. Make sure that you take note of these. Okay, I'll just write them, then I proceed to solving. So this is what we got after decomposing into partial fractions, right? Now let's just integrate each. So I'll just say when we integrate this one, it's going to give us natural log. No, okay, let me not use the shortcut. So first of all, we want to just remain with 1 on the numerator. So I can take 2 out, and I'll have 1 over x, right? Plus, let me use minus, because if I take negative 2 out, it's just going to be negative here, negative 2, right? Then here they'll just remain 1. There'll only be 1 there. Then here we're going to have this one plus this one. No need to simplify any further. X plus 1 power 2. Okay. So if you remember, whenever we have 1 or a constant on the numerator, then what is on the denominator? It is having an exponent of 1. This one is having an exponent of 1. This one is having an exponent of 1, except this one, right? So for these, I can simply say 2. What's the derivative of what I have here? It is natural log x minus 2. What's the derivative of what I have here? It's going to be natural log x plus 2. Now, don't do the same thing to this. With this one, no. So for this one, I'll use this trick. It's also called substitution method. So for this one, let me just differentiate it. Integrate it alone. Okay, let me just integrate this one alone, because I want you to know some certain concept. So I'll say I want to integrate 1 over x plus 1, right? So I'm having 1 on the numerator. You know that if let's not forget, it's raised to the power of 2. Now this is different, because these were raised to the power of 1. This was power 1. Now this one is to the power of 2. So we use a different approach. You use this approach whenever you have a constant on the numerator, and you're also having you're having a binomial or polynomial that's not raised to the power of 1. You do this. Use this approach. So I'll just say u is equal to x plus 1. So where is this one? I'll just put u there. So it's going to be 1 over u power 2, right? So now I'll say du. Let's now integrate this one. I can take this on the numerator, right? So it's going to be u negative 2, right? Now we can apply the power rule. So it's going to be plus 1 over negative 2 plus 1, right? And then I'll just say u is going to give us now negative 1, right? Over negative 1, right? And this one, when you simplify, I think I want to remain with some space, so I'll just continue here. Okay. Yeah, so this is going to become now negative u power 1, right? And I say that, so right now we have negative u power 1. I said that whenever you have anything raised to the power, you can bring it on the denominator. So it's going to be 1 over u, and the sign is going to change, plus positive 1. So I have negative 1 over u, just negative 1 over u, right? Now remember that u is equal to this, so I'm going to put it back where it is u. So it's going to be negative 1 over u. Now what is u? U is x plus 1. So this is the integral. This is the integral for this one. So this is my integral. So wherever I have this I'm going to put this. Okay, I hope you know now where it is coming from. So let me just start with the first thing that we wrote, which is this one here. Okay, so I'll say 2 natural log x, 2 natural log x plus 1, x plus 2. Then here I'm just going to, here where I have this, I'm going to put this. So it's going to be negative 1 over x plus 1 and plus c. Even c has already been written for us. So this is our final answer, this one here. My bad, did I just cancel? Okay, let me just rewrite it again. Okay, so this is the final answer, this one. Okay, I hope you understand. Let's go to the next question. Okay, so now let's solve this question. So this question, I know some of you might think of using what is this, integration by substitution, right? So let's try to use that one, because when we try to differentiate tan x, it's going to give us this one here, right? So you might think of using your substitution. So let's try to use it. So I'm doing this deliberately because I want to show you how we can approach this question, or what you can do in case integration by use substitution doesn't work. Okay, so my u is going to be tan, right? Tan x. This means my du is equal to, what is our du? Our du is going to be sec squared x, right? Then we say dx. We make dx the subject, right? Actually, yeah, there is dx there. So we say sec x, sec power 2 x over sec squared x. It's a cancel, right? So my dx now is going to be du over sec squared x, right? What did we used to do? We would write this. So this is actually a definite integral. So we begin by integrating. Yeah, so we begin by integrating. So where this tan, I'll put u. Where this sec squared x, I'll put, I'll just write it the way it is. I won't substitute it with anything. Then where this dx, I'm putting there times du over sec squared x. Now, there are some situations whereby it might appear like integration by use substitution might work. Like in this case, we've confirmed that when you differentiate this one, it's going to give us what is here, right? But if you remember, for you guys who have subscribed to Apple's Academy, I taught that when I was teaching the substitution method, I said that whenever you substitute, like what we have just done here, we've substituted dx with this one, right? We've substituted x with u. Whenever you substitute, something has to be cancelled out. That's what I taught, right? Now, in this case, what is going to be cancelled out? Like, what's going to cancel the other? Nothing, right? So, since there is nothing to cancel out, it means that substitution method is not the right one to use. We need to maybe try to tweak this one a little bit. Okay, I'm not saying that we are not going to use substitution method. It might be maybe the right method, but not using it directly. It means that maybe you have to simplify the expression, the initial expression which they have given you, this one. You might maybe need to simplify it a little bit, then you apply substitution method, not just directly. Of course, if the question was like this, let's say maybe if sec squared was on the numerator, then tan x was on the denominator, then they gave you dx. This would have worked, okay? I'm sure I've solved in my other videos on our platforms. I've solved this question. It was, I think, there in the tutorial sheet for 2023. I've solved this question. Yeah, and you saw that it worked, right? Yeah. Now, this case, it won't work. Now, it doesn't mean that the question is invalid. No, the question is 100% valid. So now, what you do is that you're going to simplify this expression here a little bit. But how? So first of all, you have to remember that tan x is equal to sine x over cos x, right? Remember this identity. The other identity that you have to remember is that sec squared x is equal to 1 over cos squared x. So these two identities are what we are going to use. Okay, now what we're going to do is that while it is tan x, I'm going to substitute this one. While it is sec squared x, I'm going to substitute this one. Then we simplify. Then what we're going to end up with after we simplify is what we are going to integrate. And what will determine, we're going to determine the method that we are going to use, because there are many methods that we can use to integrate. Okay, so let's simplify. So while it is tan x, I'll say, let me say sine x over cos x, right? And then, so here is like this divide by this one, right? So I'll just say divide by 1 over cos squared x. So now remember that this one, I can swap them, then I introduce multiplication here. I hope you remember that grade 1 approach we used to learn back in the days when we were in grade 1s, those days of grade 1s. So times, this comes on the numerator when we introduce multiplication here, then this one here, right? They like swap positions. So now finally, here it's like you are having two cos. Let me just try to cancel this one. I can also write this as times cos. It's like I have 2 cos x multiplying. If I don't want to put the power 2 here, okay? If you don't want to write them like this, you can just write power 2 here. So this one can cancel with 1 cos x here, right? And what am I going to remain with? I've just remained with sine x cos x, right? Now this is what I'm going to integrate. Let me just rewrite it because I've run out of space. Okay, so let's proceed now. So now this is now what we're going to integrate. So now which method can we use here? You know that substitution can work, right? Because when I integrate this, when I differentiate this one, it's going to give me the other one. Even this one, remember, if I differentiate cos x, I'll get negative sine x. But if I differentiate sine x, I'll get positive cos x. So this one is more accurate, right? So I'll make you my subject. You my subject, then I equate it to sine x. Then I'll say du is equal to, what's the derivative for sine? It is simply cos x, right? Dx. Make dx the subject over cos x over cos x, right? Hence dx is going to be equal to du over cos x, right? Okay. Now, why is this dx? I'm going to substitute this one. And let me just rewrite it. Remember, this is definite integral. So at first, I have to integrate, then substitute the limits. We have the upper limit here, and we have the lower limit here, which is simply 0. Okay, so I'll just write, while the sine, I'll put u cos x. Then, while there's dx, I'll put du over cos x, right? So this and this will cancel, right? Then I'll just remain with u du. Yeah. Now let's integrate u. So u is like I tell you to integrate x. How can you integrate x? We use that rule that 1 plus 1 over 1 plus 1, right? So we're going to end up with 2 over 2. Makes sense, right? So now, what is our u? Our u is simply sine x raised to the power of 2 over 2. This one I can also write it as sine squared x over 2. Now, for some reasons, I'll just consider this one, like I'll go with this one. Okay, if you want, you can even say plus c, but this is not your final answer. You've just found the integral. Now, to find the final answer, we need to substitute the limit, right? So I'll just say sine x to the power of 2 over 2, right? So here I'll put the upper limit, which is pi over 2. Pi over 2 is 90 degrees, right? And then minus. Then for this one, where it is x, I'm simply going to put 0, which is the lower limit. So I'll say So now right now your job is to just simplify. Sine, where this x, I'll put pi over 2 and power 2 over 2 minus sine 0 power 2 over 2. Okay, so now what we're going to do right now is that let's just simplify. So if you do remember, what is sine 90 degrees? It is 1, right? Here's 1. So yes, like I have 1 by 2 over 2 minus sine 0 is going to give you 0 over 2. It is still going to be 0, right? So here I'm going to remain with 1 over 2 minus 0. So basically your final answer is just going to be 1 over 2. I hope that you understand. Let's go to the next question. Okay guys, so now let's solve this question. Question 6. So I'm just remaining with 2 questions, right? Yeah, I've just challenged myself. I know some of you won't even finish the video. Some of you might even doze eventually, but me, I'll finish solving the question. So it's up to you whether you finish watching or maybe you watch it at fast forward. Let's solve this question. So you know that if I find the derivative for this one, this square root of x that they have passed here in this function, trigonometric function, is going to give me 1 over 2, something like this, right? When I integrate this, it's giving me another square root of x that's on the denominator. So basically it's giving me what is here when I differentiate this one. So this means that I can make u to be equal to what they have passed here. So my u is going to be this one, right? And then let's find the derivative of this one. So du is equal to it's equal to 1 over, what's the derivative for this one? Use chain rule here. I thought for you who have watched my videos, if you haven't watched the videos, go and watch. Okay, for those of you who have subscribed, there are 4 videos where I taught chain rule and how to deal with these questions. So when I differentiate this one, I'll get 1 over 2 square root of x. This is what you get, then dx. Now my goal is to make dx my subject, so I'll just cross multiply. So I'll say du is equal to, du times 2 square root of x is equal to dx, right? So now we found our dx. Let's now substitute in this one. So this is another definite integral, and you first have to integrate, then you find the limits. You find the final answer by substituting the limit. Okay, so basically I can just write like this. When I write cos, remember that I've said this is equal to u. This u is equal to this one, not this one, no. So I'll say, so right now I'm just going to say u instead of writing this one because I've equated it to u. Okay, because it is this one that's going to give me the derivative having square root of x on the denominator. It's this one when I differentiate it. Yeah, so let's write, and this one I'll just write the way it is. Then where there's dx, I'll put this one. So I'll say du times 2 square root of x. So you know that this and this can cancel, right? And I'll remain with one constant, right? This 2 is a constant. So I can take 2 out. Out, and I'll remain with cos u du, right? I'll remain with cos u du. Now, if I remain with this cos u du, I can now proceed and integrate cos u. What's the integral for cos? The integral for cos is just sine, positive sine. So my final answer is going to be 2 sine u. Yeah, and then where is u? I have to put what? Remember that we said u is equal to square root of x. So I'll say like this. Okay, so let me just do this. At least they look more representable. Now we're not done yet. I need now to apply the limits. So I'll just write this again. So sine minus 2. There's nothing to divide here, right? So here I'll put the upper limit, which is pi squared, pi power 2. Then here I'll put the lower limit. The lower limit on this one, which is simply 0. Okay, so we say 2 sine. Then where it is x, I'm putting pi power 2 minus 2 sine square root pi power 2. Okay, no. Here we're putting 0, sorry. So we have the upper limit, that was pi power 2. I'm just trying to show you how they are. Then the lower limit is 0. So the upper limit, we've put it here, the lower limit, which is 0. Yeah. Now we're good to go. Now, this power 2 and the square root, they can cancel, right? So I'm going to now have 2 sine pi, okay, minus this 0. It will still give me 0, even if it's under the root. And when I have 0 here, sine is going to be 0 as well. So I'm just going to have 0 here. Now, pi is 180, right? What is sine 180? 0 again. So you have 0 minus 0. So the final answer is 0. And don't even feel guilty. Answers come out like this, 0. Just write 0. Don't even be afraid. As long as you followed the rules, you've integrated, you've substituted the limits, then you are done. Let's go to the next question. Okay, let's look at this question, which is a little bit tricky because we can't directly integrate this one. Integration, I think, is just one of the concepts whereby you can't just apply it directly always. Sometimes you have to simplify a little bit, then apply. Okay, unlike differentiation, whereby if it was differentiation, we would have used chain rule, right? Now here we can't use chain rule. It can't work. There's no chain rule on integration. So we are going to simplify this one a little bit. So let me just give you a tip. Whenever they give you to integrate any trigonometric function that is raised to the power of 2, you have to do what I'm going to do, okay? So you are going to use the identities for double angles. Do you remember those identities for double angles? Which was, I think, cos add 2, right? And we are going to use the one that is having sine squared x. It's, I think, the one that has got cos, right? If I'm not mistaken. Okay, you need to use the one that is having sine squared x. So, which is this one here. This is the identity for the double angle for cos, right? Which is 1 minus 2 sine squared x. This one. Do you remember this one? So this is what we are going to use. Now, how are we going to use it? I don't know if you remember how we used to drive this one. We started by using the compound angles, then the sum and product angles. So those angles, then you, if you were forgotten, go and watch the video for trigonometry introduction. The first video, I taught these things. Yeah, but I hope you remember this identity, or at least listen. What's very important is that you are able to remember this one, or you are able to reach here. Okay. But if you are still struggling, don't worry. I'm going to show you an identity for this one. Okay? So your goal right now is to just make sine squared x the subject. So what I'm going to do is that I'll just take this one on this side. So I'll say 2. It's going to become positive, right? 2 sine squared x is equal to, and then this one I'll take it on the other side. 1 minus, let me just write that properly. This is minus 1 minus cos 2x. Right? Now I need to remain with sine squared x. So I'll divide through by 2. Divide through by 2. So we are going to have sine squared x. You are going to have 1 minus cos 2x over 2. Yeah, so now this is the identity that we're going to use. That's very important. Now, how are we going to use it? We're just going to substitute what is sine squared x. So now I'm going to have pi over 2, pi over 6. Then here I'll write 1 minus cos 2x over 2. Over 2. Yeah. Now this is what you are going to integrate. Now, how do you integrate this one? So, do you remember that if you have been given a plus b over c, you can also write this as a over c plus b over c. That's the concept that you're going to use here. So, I can do this. I can say 1 over 2 minus cos cos 2x over 2. Do you remember this? And then now at this stage you can just use any method you want. So me, what I'm going to do is that I'll just factor out 1 over 2. Then I'm going to remain with, here I'll remain with 1. I've just factored out 1 over 2. If you want, you can multiply it back. Then here I'll just remain with cos 2x. Then finally we can start now simplifying, or I mean integrate this one. I mean, let me just write it like this: 1 over 2, right? Which is going to be times the integral for 1 minus the integral for cos 2x. Yeah. So whatever you're going to get, you multiply 1 over 2 throughout after you integrate. Okay, so we have this one. So now, what's the integral for 1? You know that it is x, right? So times x minus, what's the integral for cos 2x? You know that it is sine 2x over 2. I taught these identities. I hope you remember. For you guys who have subscribed, I hope you remember. So now you can just multiply through if you want. So I'm just going, but not if you want. Since for this question we need to substitute the limits, I just have to multiply back. So this is going to be x over 2 minus sine 2x over 4. Yeah. And if they didn't give us the limit, we can just end here. Now, since what I just read it should be over 2, not over x, over 2. So if they didn't give us limits, we would have just ended here. So the upper limit, now this is the trick that I'm going to do. I mean that I'm going to use. So I need to substitute, right? I need to apply the limits. Let me give you a trick. Whenever you see that after you integrate, you end up with an expression looking like this, whereby you have maybe 2 or more fractions that are subtracting or adding up. Try to leave them as a single fraction, then substitute. Like, it will be very easy to you to simplify. It will be very easy for you to simplify. So I'm just going to say the common denominator is 4. 2 into 4, it is 2, right? 2 times is going to give us 2x. This into this, it is 1, so it's just going to give us sine 2x. Yeah. So now this is my final one that I'm going to consider. So now I'm just going to say, so the upper limit is the one that I'll begin with. The upper limit is pi over 2. So I'll put it in parentheses. So say 2x minus sine 2x over 4, right? And then minus, so while it's x, I'll put the upper limit for this side. Then I'll write that again, where I'll just show you where I'm going to put the lower limit now. Same thing, 2x, right, over 4. Okay, so where is x? For this one, let's start with this one. We've just substitute the upper limit. So I'll say 2. What's the upper limit? It is pi over 2, right? And the minus sine 2. Where is x? I'll put pi over 2. Yeah, let me just even put it in brackets. then we come to this one. So here I'll put the lower limit, which is pi over 6. So it's going to be 2 pi over 6 minus sine 2 pi over 6. This times, guys. It's like they're multiplying. Okay, then over 4. Then you now start simplifying. So what I'll do right now is that, you know that this and this can cancel, right? So I'll just remain with pi. And this can cancel, right? So I'll just remain with pi as well, right? So I've just remained with pi here. Then here I've just remained with sine sine pi over 4 in parentheses or brackets if you want, and then 2 into 6 it is 3. So basically here I'm just having pi over 3, right, minus sine, and here I'm having pi over, because 2 is going to enter into this one 3 times, so like even here I have pi over 3 over 4. Step by step, simplify. So one thing that you need to remember is that pi is 180, right? And pi over 3 is 60 degrees. Yes, pi over 6 is 30 degrees. Pi over 3, it is 60 degrees. So let me ask you this. So this one is pi here. I'll just write pi. Now what is pi 180? What is sine pi? Sine 180 is 0. So I'll say minus 0 over 4. And we do this. Minus pi over 3. So I'll just write pi over 3. Minus, what is pi over 3 is 60. So what is sine 60 degrees? Sine 60 degrees is giving me square root of 3 over 2 over 4. So now your job is to just simplify. Whatever you're going to end up with will be a correct answer right now. Your job is to just simplify. So what we are going to do is that, let's get what is on the numerator and make it a single fraction. So here I know that I have pi over 4, right? Pi over 4 minus. So let's make this as a single fraction. If we make that as a single fraction, it's giving us 2 pi minus 3 square root 3 over 6 over 4, right? Let's proceed on a separate page. So right now, your job is to just simplify. Okay, so how do we simplify this one? So you multiply this denominator with this denominator, or you can write that this divided by this thing, when it comes there, it's going to eventually multiply with 6. So just simplify this. You know how to do this. These are some of the basic concepts. So let me just write this part. Minus, it's going to give me 2 pi minus 3 over 24, because 6 times 4 is 24, right? Yeah. So now again, make this a single fraction. Let me just tell this. Let me tell you this. Try it by all means to end up with a single fraction. Yeah. Try by all means to end up with a single fraction in this case. Don't just leave your answer like this. So let's do that. This is 24, right? So find the common denominator is 24. This into this one, it is 6, right? 6 times there, it is 6 pi. This is 1, then minus 2 pi minus 3 square root 3. Okay, so 6 pi minus 2 pi is equal to 4 pi, right? Minus 3. 24. Yeah, something like this. I don't know if you have made any miscalculations. You know, anybody can make a mistake, right? But at least try to follow the concept, the procedure. Yeah, the procedure is still correct. So, and finally, let's go to the last one. Okay, now we have another question. And for you who have subscribed, to remember what I taught, that whenever you see that the fraction is having algebraic expressions, it means that we have to use integration by partial fractions. So we need to decompose this into partial fractions. So let's proceed. So I just write, let's first begin by decomposing this one into its partial fractions. So over x plus 1 equate to, so we say a over x plus b over x plus 1, right? So we multiply this one throughout. So here I remain with x plus 3 is equal to this multiplied throughout is giving me a x plus 1 plus multiply this throughout is giving me just bx, right? I think this one is very simple. And in what I like about these kind of questions, like the partial fractions which they bring, or the fractions which they bring on integration, that requires you to apply the decomposition of partial fractions, they are usually not that complicated, unless maybe sometimes, but usually they just like bringing these kind of simple ones, unless otherwise. So I can expand this one. You can use whichever method that you're comfortable with. Me, I'm going to use this one because I'm comfortable with this method, where I multiply through, equate the corresponding one. So I'll say 1 is equal to a plus b, then I'll say 3 is equal to a. So already I know my a, so I can make b the subject there. I can make b my subject, so I can just say this is my first equation, right? This is my second equation. We already know our value of a from the second equation, so let me just make b the subject. So I'll just write 1 is equal to a plus b. I'll say 1 minus a is equal to b, right? So 1 minus a is 3, b. This is negative 2, if I'm not mistaken. So b is negative 2. Okay, so we know that a is 3 and b is negative 2. So let's just substitute here. So it's going to be, so now this is what we're going to integrate. And this one, there are no limits, right? So we are going to integrate this one. So where this a, I'm going to substitute 3, right? 3 over x. And where this b, I'll say, let me just put minus here because of this negative. So I'll say negative 2 over plus 1. Okay, and even this one, let me just write them properly now. So basically I'm supposed to write 3 over x minus 2 over x plus 1. Okay, so now for you guys who remember, I think this is the simplest question so far. I mean, I can't believe I'm done already. So of all the questions that I've solved so far, this one is the simplest. I mean, within a minute, I've already solved this one. Within a minute. So here is going to be 3 natural log x. Remember this concept. Here is going to be 2 natural log x plus 1. If you don't understand here, watch where I solved question 4. I think I explained everything from scratch and I won't manage to do that again. Because the purpose is to solve. And at least while solving, I'm even explaining a little bit. So somebody's asking, why natural log? Listen, you have a constant on the numerator. This is a constant, right? You are having an algebraic function that is raised to the power of 1. Here it's like this power 1 here. Here it's like this power 1. So you use natural log, you pass what is here and what is here. Then in front you put the constant. Maybe I've given you a trick. Then you say plus c. So just like this, you are done. So I think these are all the questions requiring integration that I thought of solving for you guys. And I hope that you've benefited from this. And probably the questions that they'll bring on their sessionals, I don't think they'll exceed what I've just solved. Because, okay, maybe they might, but I don't think they'll bring concepts that are beyond what I've just solved. that is on these kind of integrals. I know there are other questions like application of application of integrals. Yeah, but that's not what I've solved already. Maybe they might bring that topic. I know maybe they might bring that. That's subtopic. But for these kind of questions, I don't think they'll go beyond what I've just solved. Okay. So make sure that you watch the video over and over again if you haven't understood. And if you're somebody who haven't even understood the basic concepts, make sure that you subscribe to A+ Academy's platforms. We have our app where you access the full videos for math, biology, physics, and chemistry. Even the solved materials, even your test 3 has been solved. The test 3, where most of the questions will come from on trigonometry and calculus, has been solved. When you subscribe, you're going to access it. So feel free to contact me. Feel free to contact me on this line. If you haven't understood calculus, you're going to watch simplified videos for calculus and other topics so that you can catch up. And don't forget to subscribe to the YouTube channel. Make sure that you subscribe, and hope that you have a very nice day.
It might not happen today. It might not happen tomorrow. But there's one thing I know for certain. If I give up, it will never happen. If I give up, I will never know how far I could have gone. If I give up, I will never know how great I could have been. I will never give up. I will never give up. I will never give up.
I never give up. When I've come so close, I can feel it all around. It's got me in ghost. Winners never quit. Quitters never win. Fall 7 times, stand up again. I never give up. Keep going and keep growing. I need no one. Just keep showing up. When I sit back and add it all up, enough is not enough. I'll never give up. You can say a lot of things about me. That I'm cold, that I'm scared, that I'm weak. But you can never say that I'm done. I'll be the one to streak. You can't beat the soul that won't give. Going full speed to the point they can't yield. It's not one step back, move onward. With every stride I take, I just get stronger and stronger. To build legacy, because I better be better than anyone in my family. I never give up. The next time I'll give it a rest is when I start a bonfire at the top of Mount Everest. Cross the Sahara barefoot, heading west, until my default is better than the best. No restraints, finally cutting it loose. I found purpose, gotta see it through. I never give up. When I've come so close, I can feel it all around. It's got me in gold. Winners never quit. Quitters never win. Fall 7 times, stand up again. I never give up. Keep going and keep growing. I need no one. Just keep showing up. When I sit back and add it all up, enough is not enough. I'll never give up. Failure's not a mistake, it teaches lessons on how much more you can take. The reality is I'm not unstoppable. The plot twist is I'm the only one who can pump the brakes. Screeching stops, progress lost. Quitting free now with a long-term cost and taxes that I write off with practice. I fight off with passion, flip the word on his axis. I laugh at distractions, cause there's a bigger picture past the closed captions. To write the ship as a sole captain, I go overboard and cut anchors and any other noise. I'm willing to go against the grain. Pain now and pain later don't feel the same until every ounce of energy is drained and I can't use my brain. I'll never give up. The mission is to gain a new skill that scales up the greatest tower. I'll never give up. Don't listen to those who can kill my drive. I will not be turned into a coward. I'll never give up. Strong opinions of me, not from me, are not real, cause I'm louder. Conviction is a human will